Right now, as you watch this video, approximately 7 octillion atoms are working together inside your body. That's a 7 followed by 27 zeros. If you counted 1 atom per second, you'd need 221 quintillion years to count them all. The universe itself has only existed for 13.8 billion years. But what if I told you that number is actually the easy part to comprehend? The truly impossible number is this. The size difference between the smallest meaningful length in physics and the largest known structure in the universe is approximately 10 to the power of 62. Written out, that's a 1 followed by 62 zeros. And here's what will genuinely break your brain. Scientists just discovered in July 2025 that the universe is even larger than we previously calculated, stretching an almost incomprehensible 94.2 billion light-years across. The scale of existence is so extreme that it defies human comprehension entirely. We evolved to understand distances we could walk, objects we could hold, threats we could see. Nothing in our evolutionary history prepared us for quarks or superclusters. Consider this comparison that might help or might make things significantly worse. If a single proton were scaled to the size of Earth, an actual atom at that scale would be larger than our entire solar system. A human cell would span the distance to the nearest star, and you, a living human being, would stretch across the entire Milky Way galaxy. But we're not even close to the largest scales yet. The largest known structure in the universe, the Hercules Corona Borealis Great Wall, now measured at 10.9 billion light-years across, would be so incomprehensibly vast at this scale that no analogy could capture it. Scientists around the world are genuinely baffled by one fundamental question.
The universe is vast
How can
and
a single
wondrous.
universe contain such impossibly different scales, all operating under the same physical laws? What connects a quark to a supercluster, and why does the universe seem perfectly tuned for complexity to emerge at every single level? Stay with me here, because by the end of this video, you'll understand the complete hierarchy of existence, from the quantum foam of space-time to cosmic structures so large that light itself needs billions of years to cross them. To understand the full scale of our universe, we need to start at the absolute bottom and work systematically upward through 62 orders of magnitude. The smallest meaningful length in physics is called the Planck length, measuring approximately 1.616 times 10 to the negative 35 meters. This isn't just an arbitrary small measurement. According to quantum mechanics and general relativity, space-time itself becomes meaningless below this scale. The very concepts of distance and direction break down entirely. To give you perspective on how small this is, if you could somehow magnify a single atom to the size of the entire observable universe, the Planck length would still only be the size of a small tree. Moving upward, we encounter quarks, the fundamental particles that build protons and neutrons.
The universe is
Quarks
vast
are approximately
and
10 to the negative 19 meters
Our
across,
journey has just
though
begun.
physicists debate whether they have any size at all. They might be truly point-like mathematical abstractions with mass but no dimension. 3 quarks combine through the strong nuclear force to create protons and neutrons, which measure about 10 to the negative 15 meters or 1 femtometer. Your body contains approximately 7, followed by 27 zeros protons right now, each one a seething quantum storm of quarks, gluons, and virtual particles appearing and disappearing billions of times per second. Electrons orbit atomic nuclei at distances of approximately 10 to the negative 10 meters, creating atoms. But here's something strange most people don't realize. Atoms are 99.99996% empty space. If an atom were the size of a football stadium, the nucleus would be a single marble at the center, and the electrons would be dust particles orbiting somewhere in the parking lot. This means you are almost entirely empty space. The atoms in your body don't actually touch. They hover near each other, repelled by electromagnetic forces. The sensation of solid matter is an electromagnetic illusion your brain creates to navigate reality. Atoms bond together to form molecules. A water molecule measures just 2.75 angstroms across, but DNA molecules, while only 2 nanometers wide, can stretch over 2 meters long when fully uncoiled. The DNA in your body, if stretched end to end, would reach from Earth to Pluto and back 17 times. Here's where things get genuinely strange. Molecules combine to create cells, the fundamental units of life. A typical human cell measures approximately 10 micrometers in diameter, containing roughly 100 trillion atoms organized into billions of molecules working in concert. Each cell is a microscopic city more complex than any technology humanity has ever created, processing millions of chemical reactions per second. Your body contains approximately 37 trillion cells. That's 37 trillion microscopic cities, all coordinating perfectly to keep you alive and reading this sentence. What I'm about to reveal takes us beyond anything you can directly experience. We're leaving the realm of things you can touch, see, or even imagine accurately, and entering scales so vast that light itself becomes impossibly slow. If this kind of cosmic perspective fascinates you, that subscribe button is right there. The scales we're about to explore get progressively more mind-bending, and I promise you, by the time we reach superclusters, your entire understanding of your place in existence will have fundamentally transformed. Let's continue our journey upward. You stand approximately 1.7 meters tall, making you roughly 10 trillion times larger than the atoms composing your body. But in cosmic terms, you're incredibly, almost invisibly tiny. A barely visible speck on a small planet orbiting an average star in an unremarkable region of an ordinary galaxy. Earth measures approximately 12 at 142 kilometers in diameter. To reach this scale from atomic dimensions, we've traveled upward through approximately 17 orders of magnitude. If you could somehow line up 80 billion humans shoulder to shoulder, they would span Earth's diameter. The Moon orbits Earth at an average distance of 384,400 kilometers. Light, the fastest thing in the universe, takes 1.28 seconds to travel this distance. When Apollo astronauts communicated with mission control, every conversation had a noticeable delay. At cosmic scales, even light becomes frustratingly slow. Earth orbits the Sun at 149.6 million kilometers, a distance so important astronomers named it the astronomical unit. Light takes 8 minutes and 20 seconds to cross this gap. The sunlight warming your skin right now left the sun before you finished your morning coffee. Our solar system extends far beyond the familiar planets. The Kuiper Belt, home to Pluto and thousands of icy worlds, stretches from 30 to 55 AU. The theoretical Oort cloud may extend to 100,000 AU, nearly 1/4 of the distance to the nearest star. In 1838, astronomer Friedrich Bessel achieved what many considered impossible, measuring the distance to another star. Using stellar parallax, the apparent shift of nearby stars against distant backgrounds as Earth orbits the Sun, Bessel determined that 61 Cygni lies approximately 11.4 light-years away. This breakthrough proved conclusively that stars were distant suns, not points of light on a celestial sphere. The universe suddenly became incomprehensibly larger. The nearest star system, Alpha Centauri, lies 4.37 light-years from our Sun. If you could travel at the speed of the fastest spacecraft ever launched, NASA's Parker Solar Probe at 700,000 kilometers per hour, reaching Alpha Centauri would still take over 6,000 years. In 1920, astronomers Harlow Shapley and Heber Curtis engaged in the famous Great Debate about the nature of spiral nebulae. Were they gas clouds within our galaxy, or separate island universes entirely? The question was definitively settled in 1924 when Edwin Hubble identified Cepheid variable stars in the Andromeda Nebula, proving it was a separate galaxy approximately 2.5 million light-years distant. With this single observation, the known universe expanded by a factor of hundreds of thousands. But here's where it gets truly crazy. Our Milky Way galaxy measures approximately 100,000 to 180,000 light-years in diameter and contains between 200 and 400 billion stars. Light, traveling at 300,000 kilometers per second, needs 100,000 years just to cross from one edge to the other. Every star you can see with your naked eye lies within our galaxy. They represent a tiny local neighborhood in a cosmic metropolitan area of staggering proportions. The Andromeda Galaxy, our nearest large galactic neighbor, contains approximately 1 trillion stars. In roughly 4.5 billion years, Andromeda and the Milky Way will collide and merge, creating a giant elliptical galaxy astronomers have already nicknamed Milkomeda. But galaxies don't exist in isolation. They cluster together through gravitational attraction, forming increasingly larger structures. The local group contains over 80 galaxies, spanning approximately 10 million light-years. This includes the Milky Way, Andromeda, the Triangulum Galaxy, and dozens of smaller dwarf galaxies, all gravitationally bound to each other. The local group is itself just a tiny outlying component of a much larger structure, the Virgo supercluster. Containing approximately 100 galaxy groups and clusters spanning about 110 million light-years, the Virgo supercluster contains over 2,000 individual galaxies. In 2014, astronomers made a discovery that completely redefined our cosmic address. Using three-dimensional galaxy velocity maps, researchers identified a superstructure they named Laniakea, meaning immeasurable heaven in Hawaiian. Laniakea contains over 100,000 galaxies spanning 520 million light-years. It includes our Virgo supercluster, the Hydra Centaurus supercluster, and several other massive structures, all flowing gravitationally toward a mysterious region called the Great Attractor. But even Laniakea is not the largest structure. The July 2025 ESO study confirmed that the Hercules Corona Borealis Great Wall measures approximately 10.9 billion light-years across, making it the largest coherent structure in the observable universe. Light from one edge of this cosmic wall left when the universe was less than 3 billion years old and still hasn't reached the other side. The observable universe itself measures approximately 94.2 billion light-years in diameter, according to the latest measurements. It contains approximately 2 trillion galaxies, each averaging hundreds of billions of stars orbited by trillions of planets. Dr. Helena Marconi, lead author of the 2025 study, stated, "We exist at an intermediate scale in the universe, almost precisely between the Planck length and the cosmic horizon. This might be a prerequisite for conscious observers to exist at all. But just when you thought you understood the complete picture, here comes the information that keeps cosmologists awake at night. The observable universe is not the entire universe. It's simply the region from which light has had time to reach us since the Big Bang, 13.8 billion years ago. The actual universe might be vastly, perhaps infinitely, larger." 3 competing theories attempt to describe what lies beyond our cosmic horizon. Theory 1. The universe is finite but unbounded. Like the surface of a sphere, you could travel in a straight line forever without ever reaching an edge, eventually returning to your starting point. Some calculations suggest the entire universe could be 250 times larger than the observable portion, containing 15 million trillion times more galaxies. Theory 2. The universe is genuinely infinite, extending forever in all directions with no boundary whatsoever. In an infinite universe, anything that can exist will exist somewhere, including exact copies of you, reading this exact sentence on exact copies of Earth infinitely many times. Theory 3. Our universe is just one bubble in an infinite multiverse. Each bubble universe might have different physical constants, different dimensions, possibly different laws of physics entirely. The multiverse would contain not just all possible arrangements of matter, but all possible types of matter and energy. Here's what makes this even stranger. The James Webb Space Telescope has observed galaxies existing just 300 million years after the Big Bang that appear surprisingly mature and massive, as if they evolved for billions of years that shouldn't have existed yet. These impossibly early galaxies challenge our models of cosmic evolution. Meanwhile, measurements of the universe's expansion rate from different methods disagree by about 9%, a discrepancy called the Hubble tension. This disagreement might indicate unknown physics, systematic measurement errors, or fundamental problems with our cosmological models. Dr. Adam Rees, Nobel laureate and Hubble tension researcher, has stated, "Either our measurements are wrong, our cosmological model is incomplete, or we're missing something fundamental about how the universe works. The universe might be hiding its true nature behind a cosmic horizon we can never cross. Here's what I genuinely want to know from you. Given everything we've explored, from quarks smaller than anything you can imagine to cosmic walls spanning billions of light years, which theory about the universe's true size makes most sense to you? Option A. The universe is finite but unbounded, a vast but ultimately measurable cosmic sphere we might someday map completely. Option B. The universe is truly infinite, extending forever with unlimited versions of everything that can exist. Option C. Our universe is just one bubble among infinite bubble universes in an eternal multiverse. Drop your answer in the comments with your reasoning. I genuinely read every response, and this community often identifies philosophical and scientific implications that professional researchers overlook. Your perspective on cosmic scale genuinely matters. Understanding the scale hierarchy of the universe connects directly to some of the deepest questions in physics and philosophy. The fine-tuning problem asks why the universe has these particular scale relationships. If atoms were slightly larger or smaller relative to fundamental forces, chemistry would be impossible. If galaxies formed at different scales, stars might never ignite, planets might never form, and life would never emerge. Quantum gravity research attempts to unify our understanding of the smallest and largest scales. At the Planck length, quantum effects and gravitational effects become comparable in strength, but we have no complete theory describing what happens there. String theory and loop quantum gravity offer competing approaches. Dark matter and dark energy, comprising 95% of the universe's content, operate at cosmic scales we don't fully understand. Dark matter provides gravitational scaffolding for galaxy formation. Dark energy accelerates cosmic expansion, pushing superclusters apart faster than light can connect them. The European Space Agency's Euclid mission is currently mapping dark matter distribution across billions of light years. NASA's Nancy Grace Roman Space Telescope, launching in 2027, will survey cosmic expansion with unprecedented precision. Every discovery brings us closer to understanding why the universe has these particular scales and what that means for our existence within it. The good news is that our understanding of cosmic scale improves constantly. A century ago, we thought the Milky Way was the entire universe. 50 years ago, we had no evidence of dark matter or dark energy. 20 years ago, we didn't know Laniakea existed. Each generation discovers a cosmos larger, stranger, and more magnificent than the previous generation imagined possible. The James Webb Space Telescope continues transmitting revolutionary observations every week. We are living through the golden age of cosmic exploration, witnessing discoveries our grandparents couldn't have imagined. The story of the universe, from quarks to superclusters, continues being written, and we get to witness each new chapter. But this isn't the only mind-bending aspect of cosmic scale. Next week, we explore what would happen if you could travel to the edge of the observable universe and why you would never actually arrive. After that, we examine the strangest objects at every scale, from quarks that exist in 3 colors to black holes containing 66 billion solar masses. Subscribe and hit the notification bell if you want to continue this journey through existence. Thank you for traveling with me from atoms to superclusters today. Remember, you exist at a very special scale in the universe, large enough to contemplate the cosmos, but small enough to be humbled by it. Every atom in your body was forged inside ancient stars that died billions of years ago. You are literally made of stardust, the universe observing itself, wondering at its own immensity. Keep wondering, keep questioning, keep looking up. See you in the next one.